computer and let me share my screen. Um, so today we're going to start with chapter 4, which is more shell commands. And the good news is this chapter is way, way shorter than chapter 3. So that's considered as good news. And since it's shorter, we might take this project chapter 3 exam. It's a multiple choice questions, very, very similar to chapter 1. And before we jump into chapter 4, what I'm going to do, I'm going to go and just have a review about what we covered in chapter 3. So with that being said, let me just stop sharing this screen and let me share my other screen. Now, for my other screen, I hope you guys can see the PowerPoint and the terminal at the same time. So I'm going to open my chat box and I want you guys to let me know if you guys can see the PowerPoint in the background and the terminal in the foreground. And right now I'm looking at the chat box, waiting for someone to tell me we can only see the PowerPoint. Okay. I changed the settings for this and I thought it's gonna stick. Let me see if I can. I'm just gonna stick with the with the terminal for now. And then after that, I'll switch to the PowerPoint and to the shell backward and forward. Anyway, so we can start with a review about what we covered last class. Now, last class, we start talking about the shell and what is the shell. And the shell is simply the interface program that will give you access to the kernel so you can write some commands, and those commands are going to be interpreted by the kernel, and some actions will be taken based on the command that you're writing. And if you're using the right syntax and you're using whatever options or flags you want to use with it. And we said that we have many different types of shells. We have the CSH and we have the bash. And we said bash is usually the one that's commonly used in Linux operating systems. And then we talked about echo command, and the echo command simply will show whatever you want to show on the screen. So for example, I want to show my name, and it's just simply going to print it. Now, echo it may not make sense to you right now with what I'm doing, but later on we're going to have a whole chapter to talk about scripting. And scripting is simply just like writing a program. And one of the things that we like to do in programming is to show results on the screen. So your tool for that is going to be the echo. Not only the echo can show us text on the screen, echo can also show us the value of what we call environment variables. Now, any Linux operating system comes with a group of environment variables, and environment variables simply are placeholders that store important information related to the operating system. We had an example about the echo for shell, and we can see here it's going to tell you what kind of shell you're using, and it's actually going to show you the location of that shell that we're using. We can also type echo with a $0, and it's going to tell you you're using bash here. We can type echo $path, and this is something whenever you want to install a new software in your system, probably in a lot of cases, you'll find yourself in a need to update the path. And this is simply the path. Path simply will hold the location of all the executable files that you have in your system, the libraries that you have in the system. So whenever you want to have access to them, you really don't have to tell where are they located at. The first thing that Linux is going to do is simply look into the path and see if whatever you're trying to execute is within the text that you see here. So that was the echo and the environment variables. At this point, I will say path is one of the most important variables. After that, we talked about a very, very important command, which is password, PASWD. I told you that this command will help you change the password of your user account. And I said I highly recommend everybody to change your password. So the one that I sent you should give you access to the Linux operating system, but I know it's going to be a little bit hard for you to memorize that password. So you feel free to change it to whatever you feel more comfortable with. So that was the password. Now, after that, we talked about the help resources. And we mainly said we have a command called man that will simply print the menu of any command. So if you type man ls, it's going to show you the command itself, the name, and how is it used, and a little bit of a description, and then all the options or the flags that comes with LA. And if you keep pressing spaces, it's going to go page by page. And if you want to quit at any time, we said you just press Q and you can leave. In addition to man, we have info, which is another way to show information. And info will show you a little bit more detailed information about the command, a little bit way too long comparing to man. And also, if you want to quit, just press Q. We do have another two help tools. One of them is called help, ls. Oh, wait a minute. Try help. Well, it looks like help, ls. Let me try another one. Help, cd. Oh yeah, help ls didn't work, but cd actually worked. And as you can see here, he's showing you everything. It's a little bit like a compressed version of that help. And you don't have to press Q to exit. We have another help tool, which is dash dash help. After you type the command itself and then dash dash help, and it will show you also very, very similar to the original help. So you can see here we have four different ways to show uh, information about the command that you're trying to learn. Now, some of those commands will come with a little bit of flags, and flag is simply usually, again, flag after you type the command, you type the flag after that. And there, today we're going to see that we have different styles when it comes to flags. But I can type, for example, ls, and it's just going to show me that I do have a folder called my files. But if I want to show the information in the form of a table or a list, so you type -l or -l, and it will show you a little bit more information. Compare this one to what you see here. It's telling you that this is a directory, this is explaining the permission, and this is the owner. This is the date and time that folder was created. So a little bit more information. Also, if you type AL, it will show you the hidden information as well. So all what you see here, those with dots are hidden. That simply means you cannot see them. And whenever there is a D, it's a directory. And whatever there is no D here, it's a file. So you can see here, directories are going to be recognized here with the color blue. So that's again what options or flags are. After that, we moved on and talked about other commands. One of them was the APROPSE, a propose. And then after that, we said you put a word, for example, copy, and this command simply will look into all the commands that are available in the shell and is going to search their description for the word copy and is going to give you all of them here. Well, he didn't find it. Bash propose command not found. Oh, wait a minute, did I misspell it? Let me try to rewrite it again. Propose. Oh, without the E, sorry. And here we go. So inside the shell, those are all the commands that are available in the shell, where if you go and type man with the command itself, it will simply show you that the word copy does exist as part of its description. And then we said there will be numbers associated with all these commands, and those numbers are simply going to be giving you an idea about what type of command that we have here. Is it executable? Is it a game? Something like that. So that was right after that, we start talking about path. We said there are absolute path and there's a relative path. And just to give you an idea about what's the difference between them, an absolute path simply means you start by the root and you go all the way to the final file that you're trying to have access to. Relative path, not necessary to start with the root. You simply can start with from the position that you are at, and then you just start moving forward or backward in the path itself. And we said paths in Linux are different than paths in Windows. In Linux, we go backslashes. With Windows, we go forward slash. Paths are going to be a very, very important concept, and you just need to actually practice using paths a lot. Right after that, we talked about the command pwd, which is simply going to tell you where is your location as a user in the file system. So me, this is my file, my folder, and it's simply located inside home, faculty, LGNApp. Now, of course, if you do it by yourself, it's going to show you a different file. So let me just change my directory, for example, and go to my, let me just go ahead and type a list first. So I have my file. So if I say change directory, my files, oh, why is that? It's uppercase F. Okay, now I'm inside my file. And if I type a PWD, sorry, PWD, PWD is simply going to tell you where are you right now. I made a mistake before. It's simply going to tell you where are you right now. So previously I was in my folder when I typed PWD. And when I moved to a new file folder, it showed me that this is my location. Now we said, if you want to move like inside a folder, you type change directory and you type the folder you want to have access to. If you want to go backward, double dots will take you outside of that folder. Now, if I go back to my files, and this is it. And if I want to go back to my home folder, all I have to do, change directory, and you put this simple here, and it will take you back. No matter where you are in the system. Let me show you. I'm going to get myself outside of this. Now I'm outside of my folder, and let me go outside of faculty, and let me go outside of home. And now I am in the root directory, because if I type ls, it will show you all the folders that is in the root. And if I try to get out of this root, again, ls, there is no out. You are in the last place here. This is the root directory. Now, if I want to go straight to my folder, change directory hyphen, and it should take me there, but yeah, here it is. So if I type pwd, now you can see that I am in my folder. So this is the change directory, which is again one of the most important commands in Linux, because this is what we use to navigate. We can create folders. So I will say make directory, and just like how I have my files, I will create your files. And now if I type ls, you'll see that I have two folders. And if I say -L, you will see that those are the two folders. And you can see this one, your folders. Well, this is not correct. There's an issue here. Oh yeah, sorry. January 31st. Today is January 31st, and this is actually the time. It's 6/18/19, and that's exactly the time. So this is how we create folders. What I want to do right now, I want to go to your file. So if I go change directory, your files, and in your files, it's empty at this point. If I want to create files, just type touch, and then after that, type, for example, file one dot text. Now, one thing you should know about Linux doesn't recognize extensions. So this dot text, it's simply I decided to add it. but you can totally create a file without an extension. Okay? So, but again, it's a good idea to have extensions so you can recognize the file usually. By typing that, if I go and type list, you can see that the file does exist at this point. And if I type command file1.text, file command should tell me what kind of file do I have. And you can see here, you just tell me it's an empty file at this point. Let me try to put some text inside it. So to do that, nano text editor file1.text. And at this point, I'm just going to put words, for example, ABC, and I will say RTG, and I will say ACC, and I will go BBC, and I go CMBC. I'll just keep it that way. So Command X or Control X. Do you want to modify? Yes, I do. And now I'm out. Now, if I go and type cat file1.text, it will show me what's inside that file. So that's the command to cat. Okay. So this is how we create a file. You go and type touch. And now let's go and type file. And now we'll type file1.text. And let's see what he's going to tell me. He's going to tell me that it's an ASCII code text because again, it contains those alphabetic characters. So you can see here, previously it was empty because there was no content inside it. And the moment I added the content, because the content is alphabetic characters, then the type file is the ASCII code text file. If I want to copy the file that I created, so let's just go ahead and type ls. This file one, I want to copy it. Now, where I want to copy, let's say copy cp file one.text. You have to tell me where do you want to copy it. And let's say I want to copy it inside my folder because let me just go backward. You can see that I have your files and this file here, file one does exist in your files. So I want to put it in my files. So what I need to do, I need to tell where's the location. So what I'm going to do, I'm going to put dot dot as an indication that I'm going to go outside, and outside you have a folder called my files. Press enter. So I made a copy of that file. So if I change directory and go out, and then after that, change directory to, let's go ahead and type ls again, change directory to my files. Oh, my bad. Uppercase F. And now if I type ls, you'll find that file one does exist there. So if I go say cat file1.text, you'll see the file does exist there. At this point, again, you may start asking yourself, what is the point of all of this? Why is this important? Why is it important for me to know all these commands? I'll tell you something. As I said before, Linux is all about businesses. Any business in the world, I can guarantee you, if they have servers, then their servers are going to be run in Linux. And for you to work in a company, you need to know Linux, depending on your job, of course. But in general, knowing Linux is a big plus in your resume. Now, at a certain point, once we are familiar with all these commands, we're going to be moving on and talking about how do we create scripting files. And when you type scripting files, you're going to start learning about automation. And then after that, you're going to learn about monitoring the Linux operating system performance. So learning all these commands simply will give you full control over the server. And when you have full control of the server, simply you can manage it, you can monitor it, you can fix problems when they happen. And that's the whole point of what we're doing. So the process starts step by step. And the first thing you have to know here is to learn about these commands and get familiar with them. And this is what we're doing in those first two chapters. Now, just like how I was able to copy the file from the folder that I had before, I can move files from one folder using a command called mv. And it works very, very similar to the concept that we have with a copy. Now, if I want to remove a file, there is a command called rm, and let me just cat my file. I want to see what's inside it. Oh, I don't want to remove this one. I want to keep it. This is a text file that I created last week where I just put some codes here about education. Now I want to keep that. Let me just touch new file dot text. And now if I go list, you see, I have a new file. If I want to remove rm new file dot text. Now, if I press enter, that file is simply going to be removed. And remember here, there is no recycle bin. So once it's removed forever. So if I press enter, and if I go ls, you'll find that it's not there anymore. Now, when you want to remove a folder, that's a totally different story. So let me just go ahead and exit this folder. And as you can see here, I have two folders here, your files and my files. Let me try to remove your files. So if you're the folder, your files. Now, if I press enter, it's not going to be acceptable. You cannot remove a folder. But if I want to actually do that, I have to put this option, -F. And -F usually, not only in this case, but a lot of other cases, is to force it. Let's see here. If I type ls, now it's gone. Oh, no, it's not gone. Cannot remove your file. It's a directory. Huh. Let me see here. Oh, wait a minute. No, my bad. It's R, not F. R is for recursive, and now it's gone. Okay. So this is pretty much what we talked about last class. And there is other free commands, which is less and head and tail. This is when you have a text file that's big and you just want to show, for example, uh, first few lines or the last few lines of that text file, or you want to show the whole page, the whole text file page by page. So we have those three commands to get the job done. This is, again, what we talked about last class. This is, again, just a summarization but for what we talked about. And now we're going to start a new chapter. And as I said, the new chapter probably will not take more than 45 minutes starting from this point. So unfortunately, I'm going to have to keep going backward and forward between the PowerPoint and the terminal. Let me see if I can actually. No, it's not going to work. I'm pretty sure you guys only can see the terminal at this point. Can you see the PowerPoint? Nope. Okay. So let's go and talk about the PowerPoint, and I'm going to switch back to the terminal every once in a while. So first thing we need to know in this, wait a minute, I think oh, no, sorry, this is the wrong file. I opened the wrong file. We're supposed to have this one here. I will download the file in a sec and open it. Okay. Come on, open. And I think you guys can see it now. Let me make sure. Yep, okay. More commands. Let's start with this one. Okay, first thing we're going to talk about is processes. Now, your Linux operating system, when it's running, there are a lot of programs are executing in your Linux operating system that you simply don't see, and they are simply executed in the background. So not only the shell that you see is executed, a lot of other programs are executed in the background. We call those programs processes. Now, this is very, very similar in Windows. When you press Alt-Control-Delete, and then you press on the Task Manager, and then the window that's going to pop for the Task Manager, and you click on the processes, and it will show you a long list of programs that are executed in your program. Same thing in Linux. A lot of programs are executed in the background and some of them in the foreground that are running. So each one of those programs, you should know, has a very, very unique number. It's called the PID, the process ID. Now, why is it important to know that part? Because as a Linux administrator, you will find yourself in a position sometime where are you going to open the terminal and you're going to look at all the programs are executed in the background, in the foreground, and sometimes you will see that one program looks weird, doesn't make sense, they exist in the program in the background, and it's consuming a lot of the processor power. And at a certain point, your system is crushing because of that program. So you would need to terminate that program. And the only way to terminate the program is by calling it by its number. Now, of course, you don't have to memorize all these numbers because there will be some commands that will show you all these details. So if I want to just summarize what I just said here, programs that are executed in the Linux operating system, we call them processes. Every single process has a unique ID. We call them PIDs. Now, how do I view those processes? Well, we have a single command. Well, actually, we have two commands to get the job done. The first one is called the PS. PS will simply show you all the processes that are running in your Linux operating system at the moment you pressed PS and you pressed enter. Okay. Now, PS by itself, it's a very, very complicated command. It comes with a lot of flags, and PS can get a lot of things done. But at this point, again, we are simply just going to go with very, very few of these commands. Now, just for the purpose of a demonstration, let me go back to Linux terminal and let me clear and let me type PS and here we go. Now, as you can see here, this is very, very basic table, as you can see here. It's showing me that at the moment when I pressed PS, those are the two programs that are executed. The bash, which is the terminal that the shell that I'm running, and the PS command that you see here. And it's telling me that the this is again the PID for each one of them. Okay. And we're going to talk about the TTY later. This is simply the time that they are executed at. And there should be well, okay, the next time when we're going to talk about flags is going to show you the usage of the CPU. But this is, again, a very, very simple view for the output of the PS. Now, before we jump into details, let's go back to the PowerPoint because I want to talk about here the total time of the CPU process used by the process. And this is the process names. Anyway, so this is the part that I want to stop a little bit here at. When it comes to options and flags, not only for PS command, but for other commands as well, we have three different types of options or flags that we can use. We have the Linux style, we have the PSD style. SD is system distribution, and B, it's a name of a very, very specific Linux distribution. I don't remember the exact name for it. And this is the GNU long style. So we have three different ways that we can use flags and options. And as I said, not only with PS, but with other commands. And the thing that you have to understand here, some commands, like PS, for example, will accept the three styles. Some other commands will not accept the three styles. Okay, so it's very, very important to understand which style works with which command. And as I said, it will be a good idea if you can memorize all that. But our task is not for you to just memorize all these things. My main task here is for you to, the more you practice it, the easier it gets to stick in your brain and in your head. So we have the Unix style, which is again one of the basic ones. All you have to do is to group all the commands, like for example, multiple letters. Each letter is a flag by itself. You put them all together, and before the flags, you put a single dash. Okay, and I'm going to show you an example about that. The BSD, again, you put them all in a group, but you don't use any dashes. And we're going to see that as well. And then we have the GNU, the GNU long style, which you have double dashes. Okay, so for the PS itself, I'm going to show you the three styles, and you will notice that the three, basically all of them will show me simply like the same uh, results. So first thing first, let's see here. Where is it? Here is the terminal. The first thing we have to type here is PS, and this is the Unix style, single EF. And here we go. So this command here not only is going to show you the background, the foreground, it's also going to show you the background as well. So you can see here, it's not like previously when I typed PS, let me just show you PS by itself. It's only showing me those two commands. And if I look here, I should be able to see them somewhere here. We're talking about 3186. So let's look for 318. Where's 3186? 3186. So, oh, where are they? There should be here somewhere. The PS. Well, I can't see it anymore for some reason. Let's look at the bash itself. 30794. Here it is. That's the bash. And you can see here, the owner here is me. And here's me again. I'm the owner here. Let's see if I can find El Janab again somewhere. Here it is. Oh, here it is. That's the command. They're different because I'm using -EF, it's different than this one here. So these are again the commands. This is the Unix style. And you can see here, every single command here has a
I have a
unique.
question. I'm sorry.
Yes, go ahead.
Yeah, everybody is a different PSEF, right? I got in these different number 3195.
3195?
Yeah, that my name is right here 3195. Everybody different.
Yeah, yeah. The processes, they will have different numbers.
Oh, okay.
Whatever I see will be different than whatever you see.
Oh, okay.
Those are going to be numbers that's going to be assigned by the operating system. So again, different numbers, of course, will be assigned to them.
Oh, okay. Thank
Yes,
you.
no problem. Later, we're going to see that some PIDs are going to be very, very special, especially PID number 1. It's a very, very special one. But this is something we're going to talk about, of course, later. So this is, again, the Unix style. Let's go ahead and talk about the other style, which is the BSD. If I type PS, and remember here, I grouped all my flags using a single dash. We said the BSD style, we don't have dashes. We just type the flags, and you can see here, there they are. They're going to look a little bit different, but mostly the same information. You got the PID, you got the user. Look at this. This is the CPU usage. This is the memory usage, and so on. Okay. So that's the BSD. Now, for the third one, which is the GNU style, long style, we said we use the double dashes, and usually it's not about a flag. It's not a single character. Usually, it's actually a whole word. For example, deselect. I press enter. It's going to show you the information, but again, in a different style. There it is. This is the PID. And this is the TTY, and this is the time, and this is the command itself. It's not telling you who is the user. It's not showing you information about the system and the usage of the system. So each one of them provide you with a different way to show the information. Now, one thing you should know about PS again, PS is just gonna take like a screenshot of what's going on in the with the processes, and it's simply just gonna show it to you at the time. Now, when it comes to an actual job and task on how do I monitor the performance of my Linux operating system, the command that we are going to use is simply called top. Top is going to provide you with live information about all the processes that are running in your system. And you can see here how they change. So it's just not like it's not like a screenshot at the moment you press the command PS. Top is simply going to be running in the background and it's going to keep running. So if you find yourself in a job one day working on a Linux operating system and your job is simply to monitor the performance of the system, you're going to open a terminal window and you're just going to type top and you're going to look at these numbers and make sure that everything is going smooth with no problems. You're probably most of the time are going to be looking at the CPU and monitoring those commands and which one of them is simply using a lot of CPU power. Okay, so those are the commands that are running in the background, and I'm looking at them, of course. Um, Now, if I want to get out of the top, I have to press Q, and that will take me out of it. Okay, and you can see here, most of the commands is showing me the background. He's not showing me um, me as a user here. It's all about the root and the other users, but not me. I cannot be there. And he's showing me here top command, systemd, and so on. So that's again the big difference between top and PS. Top will show you live information about the processes that are running in your computer Linux operating system. Okay, now let's move on to a topic that is as important as um, this PS and top command. How do I kill and how do I terminate a process that is running in the background? Or sorry, in my Linux operating system. To demonstrate this concept, we have a command that will not make that much of sense at this point, but it's very, very important to know what it is, and we're going to utilize it later. The command's called sleep. Sleep simply will lead to a delay. So look what I'm going to do. I'm going to say sleep for 5 seconds, and I'm going to press enter, and I'm going to count to 5. 1, 2, 3, 4. I was too slow. I have to go a little bit faster. You can see here, there was a delay. I told the computer system to sleep for 5 seconds. And after 5 seconds, I went back to the shell prompt that you see here. Okay. Now here's what we can do. We can type sleep 5 and you follow that with the ampersand. Okay. With the ampersand. Where is it? And if you do that, it's simply going to sleep in the background. Okay. So it's sleeping, but it simply just jumped to the next one. Now you may ask, so what exactly is this? Sleeping in the background will be very, very helpful if you are going to try to take advantage of the multiple cores that your processor have. Let's say you have 5 cores and you want to put one core into a sleep. Let it delay a little bit for any reason. So you can simply do that by writing a command to the specific core and writing the time you want that core to sleep or to be delayed. Okay? This concept is a little bit way more advanced. The whole point of what I'm saying here is that I just want you to know that this command here will lead to a delay. And I want you also to know that I'm going to put the ampersand so it will be a delay in the background so I can continue using my terminal. So here's what I'm going to do. I'm going to come here and say sleep. And I'm going to put 500 in a dollar sign. Okay. So we know for sure now there is as you can see here, he's telling me that the sleep 5 is done, and now we have a sleep for 500. And this 4184 is the PID for that sleep. So if I type PS, you'll see that this is the command sleep that's running at this point. And here it is. This is the PID. So if I want to stop the sleep, I can type kill, and I have to follow that by typing the number of the PID for that command, which is 84. And if I press enter, and now let me go to PS, and you will see that you don't see it anymore here. And he's telling me that this command was terminated. Okay. So this is again how we kill any process, by knowing the number of the ID of that processor. Let me just show you an example. There's another way we can kill commands. I'm going to go ahead and type sleep 500. Let's make it different. 100 with a dollar sign. And then I'm going to sleep again. This time $200 sign. And then I'm going to sleep again with $300 sign. Now, if I type PS, it will show me that I have 3 sleep commands, and those are the numbers. Now, if I want to kill them all, I can go one by one and just write the numbers if I want to, but if I want to kill them all, I can do this. Kill, I think all. Let me just make sure. Wait a sec. Yep, kill all. And then after that, sleep. And you can see here, the 3 of them are terminated. If I type PS, they are all gone. Okay. So at this point, it's very, very important to understand the PS command and the PIDs and how do we terminate any process that we want. And if you have multiple processes that share the same command name and you want to kill them all, kill all, and type the command instead of going by one with those numbers. So we are going to stop and leave the commands, the killing commands and the process commands. And now we are going to be moving on into how do we process files. This is a very, very important concept in Linux operating systems. So we'll see today a few commands that we can use to have access to files, perform some operations on the files that we have there. So let's go ahead and look at what do we have here. We have my files. And if I go inside my files folder, I can see that I have 2 files. One of them is my file and file 1. If I type file, let's go, there you go, cat file1.txt, it will show me those words. Now, if I type sort and if I type file1.txt, it's simply going to sort those lines one by one in an alphabetic order. If I press enter, and here we go. ABC, ACC, BBC, CMBC, and RTG. So if you have a text file and for any reason you want to sort the files, again, it's going to sort them based on the first character of each line. So if you have more words here, it doesn't matter. It's simply going to start with A, and it's going to see B. So B is supposed to be first, and then C is supposed to be second. And then now we're done with A. We go to the third character, which is B. There is no B, so this is going to be the third word. And then after that, we got C. That's the fourth word. And then RTG is the final word. Now, will that change the content of the file? Of course not. And here we go. Files 1, and it's simply the same. So sort, again, will help you sort the data in an alphabetic order. Why would you want to do that? Maybe you're searching for something, and having the data to be sorted will make the job a lot easier. You should know that if the file contains numbers, it's going to sort them based on remember here, the the ASCII code value, the decimal value of the characters, the digital characters, which again is going to lead to the same result, just like uh, if it's just sorting them based on the actual values. So that'll be number one. Number two. Now remember this and remember this very, very clear. The command grep. Grep is one of the most important commands when it comes to Linux operating system. Grips will allow you to search in a text file. And it's not only going to allow you to search, it's going to allow you to search for uh, with a lot of options. You can search for words, you can search for characters, you can search for patterns, you can search for words that doesn't contains characters or doesn't contains numbers. There are many, many options when it comes to the command grep. So let's go back here to my file. Let me just cat file one. So these are my files. Now, if I type grep and I want to find uh, a text file that, sorry, I want to look for words inside this file that has the character BC. And I have to title the file, so it's file one. Look what's going to happen. It's going to tell me that, oh, I found BC here, and I found BC here. Press enter. Oh, there's another BC. Here it is. So you can see here, he searched the file line by line, looking for the existence of BC, and he was able to find BC here, and BC here. Now, if I rewrite the command, but type -n here, he's only going to show me the lines. What's the number of the lines that they do exist? And he's going to show me, like ABC was line number 1, BBC was line number 4, and CMBC was line number 5. Now, you have no idea how important is this feature. In a lot of cases, you'll be finding yourself, again, Linux contains thousands of files. You can actually write a simple command that will search all the files that you have in your system looking for specific information that may exist in that file. So this, again, is just an example. Let's see, what else do we have with the grep? We can search again. Well, let's go ahead and keep going with some examples. We have many, in addition to the -n, we have other options again that we can use. And I can say, and let me show you this. I'm going to go up and I'm going to keep the E and I'm going to put space, -e, and I will say I'm going to be looking for, let's say, A, and then -e, and I will say I'm going to be looking for R. So in this case, what am I doing? I'm searching for words that contain the letter A and the letter R. Now, previously, I said BC, and that simply means BC had to be next to each other. Now, this time I want A and I want R. And I want to see the line, and you can see here, I have A in line number 1, and I have R in line number 2, and I have A in ACC. So you can see here, he was able to tell me the existence of the A, and the R. Okay, so if you have multiple patterns that you want to search for, you have to use -e and -e, and then you follow those patterns. So that was one thing. Let's see, what else do we have? I can also do the following. Let me just go backward. Oh, by the way, if you use the upper arrow and lower arrow, you can go through the history of your commands, which is going to be very, very helpful. Now, just like how I was able to search for BC, I can search for any lines that doesn't contain BC by typing -v. So it's more like a invert, sorry. So you can see here, he's shown me that line number 2 and line number 3 doesn't contain BC, and here it is 2 and 3. You may ask, what is line number 6? Well, line number 6 is an extra enter that I typed in the file. Okay, so what else we can do with the grip? Grip -n. I can use brackets. And with brackets, file one text. I can specify what am I looking for? I'm looking for the character A to C. So search for any lines that contains the characters A, B, C. And he will show you that all these characters, those are the lines that contains those numbers. Um, if I put this up and let's just go all the way to R or G. So all A to G. And you'll see that he got the G here. Okay. Let me show you what else I can do. Let me look for all the line that contains the letters, the digits from 0 to 9, and simply there is no thing. There's no numbers there. Okay. So, and by the way, this is just a very, very short introduction about grip. Grip is way more complicated than this. When we're going to talk about what they call it, not pattern recognition, it's expressions, regular expressions. We will see that we can write really, really complicated expressions between those square brackets, and it will be very, very helpful. Let's see here. There is one thing that I remember. Oh, and by the way, one thing you should understand, um, grip doesn't recognize the asterisk and the question mark wildcards. You cannot use them here. So let me just show you one thing I can do here. I'm gonna say, look, if I put this simple, it simply means that doesn't it contain A? Let me just make sure I got this right. Doesn't start with A. Or the A is not included, sorry. So you can see here, A and A are not recognized, but anything else is recognized. So let me just go ahead and put AB. Or let's just put BC. So you can see here, this one is all selected. This is all selected. Which one of them is not selected at all? The BBC, because I don't want B and I don't want C. So for that reason, it's not showing here. But anything else is actually simply showing because there's an A here, there's an A here, and there's M here. So you can see here, it's not selecting BC. So it's just showing me that there's an A here, RTG, and A, and there's an M here. So those again are the commands. This is how the grip works. And as I said, this is not the end of the grip. We are going to talk about the grip a lot in the future. Let's see here. What else do we have? I'm, by the way, looking at the PowerPoint just to make sure that I'm not forgetting anything. And it looks like so far I got everything covered. Okay, now we are going to be moving on to a different, sorry, not exits, my bad. That's the last thing I want to type, clear. How do we compress files in Linux? And this is a very, very important concept because later, whenever you download big files, in a lot of cases, those files and folders are going to be compressed. So we need to know how do we compress files and how do we decompress files. And the idea here is very, very simple. Let's go here to my file, and you can see I have two files, file one, my file. And let's say I want to compress my file. So to do that, gzip, and you type the file, so my file.txt. And then you press enter. Okay. After you press enter, if you go ls, you'll see that now I have it with an extension of gz, and it's a compressed file. Now, if I want to view it, if I type cat my file gz, and look what's going to show me. This is trash. I cannot view it that way. So if I want to have access to it again, I have to unzip it. And to do that, gun zip my file. And now if I type ls, and you can see it's back now without the GZ extension. And now if I go cat, sorry, now I get my file back. Clear. So those are the two commands that we can use to compress and decompress files, gzip and gun-zip. Now, we have another command is associated with them, which is zless. And zless will simply allow you to view the compressed file without decompressing it. So what is that supposed to mean? So if I go gzip my file, and if I go ls, and just like how I try to view it, it simply will not show me anything. Make sure that I don't have any chat questions. Okay. Now let's clear. And now if I type zless my file, and you'll see it will show me the file. Press Q, and now I'm out. So if you have a compressed file and you just want to view the content without decompressing it, then zless is the command to go with. Okay, so this is again how those compress methods works. And as I said, it's very, very important to understand those concepts. And now we are going to be moving on to the last topic of the class of today, which is archiving folders. Archiving folders simply means, and I'm going to put it in a way that it will help you understand the concept. If you have a folder that contains many, many files, and you want to send this folder as an attached file in an email, or you want to move it from one server to the other, you're simply trying to, again, send the folder from one place to another. Because it's a folder and because it contains many, many files, you will not be able to do that traditionally by just, for example, sending the folder itself. It's not going to work. So what do we do in a case like that? We will convert that file, or folder, sorry, with all the files inside them into an archive file. We have a command called tar, and tar simply, again, stands for tape archive, and it will convert the folder, the whole folder, into a file. And after you get it as a file, you can send it by an email, you can send it to a server, you can send it to any other. And by the way, just to let you guys know, if you are going to take a cloud computing class in the future, whatever I'm talking about right now, it will be very, very, very helpful to understand how the cloud system works. Take AWS as an example. AWS simply will give you access to create a Linux server that you're going to own and you're going to control. But at the same time, it's going to give you a storage space that is separated from your Linux operating system, but you can communicate with it with commands. Most of the time, all your folders are going to be stored in that storage space in a form of a tar. And every time you want to import any files and folders from that storage space, is simply going to be in a format of tar. So let's go back here to our system. I got those two files. Let me extend zip my file. And now I am getting out. Okay, so let me get out of this folder. And now if I type here my files, which is a folder, and if you go inside it, you'll find that there are two text files. Now, how do I simply use the command? The idea here is very simple. You type tar and you follow it with the folder you want to convert it to an archive file, but it's very, very important that to know that it comes with a group of options. So this is again, very, very important concept. So let's go ahead one by one and see what options do we have when it comes to uh, converting a file to an archive. The first thing I'm going to do, the command is tar, and then I'm going to try to archive this folder. Now, if I just press enter, it's not going to accept it because usually, again, you need to have some arguments. And we're going to go and add those arguments. So as I said, we have many different types of arguments. We have C to create a new archive file. We have X to extract. We're not trying to extract anything here. V is this is optional, to view the files that are processed. F, if you want to put your archive file in a specific output folder. And then you can use gzip Z, if you want to compress the text files inside the folder. So you can see here we have many, many options, and I'm going to go one by one to explain them to you. So let's start with this one. All I want to do here is to create an archive file, and I want to see the progress. Okay, so those are my options here. Press enter, and he showed me the files themselves. Let me just type ls. Oh, that didn't work. Let's see here. Oh, my bad. And then after that, I am going to type f, and I'm going to specify the archive file name that I'm going to create, and I'm going to call it, for example, send folder. Okay. Okay, let me see here. I just want to make sure that I got this right. I think I made a mistake here. What I'm supposed to do, I'm supposed to write the name. Let me just keep it simple here. I'm supposed to start with the name of the send folder dot tar, and then here I type my files. Okay, so I'm going to create a new archive file. I'm going to view the process, and the output is going to be send folder.tar, and I'm going to compress simply my files. So if I press enter, well, he exiting with a failure state due to the previous error. Where's the previous error? Okay, let me see here. If I type ls, that didn't work for some reason. Let me type F in this case. I think I should put F, yes. Now let's see if I press enter. Oh, now it worked. Now if I type ls, you'll see that send folder tar. So it's very, very important to put them all here. The -C and then V. The V is basically responsible of showing this part. So if you don't want to see this part, you can take VF. But F is very, very important because you're going to specify what is the file that you're trying to create and what is the folder you're trying to archive. Now, let me just remove send folder. If I type ls, it's gone right now. Let's go back to this one, and I'm going to take the F away, the V away, and I'm going to put Z. Z again will compress the files inside my files. And now if I go ls, you'll see it's there again. Now, because my files are not that big, so you may not be able to see the effect of compressing. And in a lot of cases, whenever the file is very, very small, compressing it will lead to increasing the size of the file. So that's why, again, you will see the effect of compressing when your file size are big, but when they are small, you simply, by compressing it, you're just going to increase the size of it. So this is just an example to show you how do we compress an archive, an actual big file into, folders with files into one archive file. Now we do have many options that let me try to move, send folder, and I'm going to move it to, where am I located at? There's no folder here. I'm going to try to move it to dash new folder. Well, of course, the new folder doesn't exist and permission was denied. So let me just go ahead and create it. So I'm going to go make directory new folder. Now, if I go ls, you'll see that the new folder here does exist. So if I say mv send to new, again, permission denied. I do not have the permission to move the file to the new folder. Let me just see if I can take this away. Yep, now it works, sorry. So if I go back here, change directory, new folder, and if I go ls, well, here, change directory, new. And if I go ls, you can see the file here. Now, if I want to extract it, okay, tar, very, very important to use. Let's go back here. We need to use X to be able to get the files out. And I can put FV to see the process, what's inside. And then after that, I can put F to a specific folder. I'm just going to go F, and then I will type the file that send folder. And let's see here. I'll just keep it this way. And now if I type ls, you'll see my files, change directory, my files, and you will see ls, and I have my files back there again. So this is the tar command, and this is how simply it works. It will give you, again, a chance to archive, simply again, convert a folder into a single file. And whenever a folder is presented as a single file, you can easily transfer it as a single file by attaching it to an email or sending it in a URL to another server or to another location. And this will be the end of this chapter. So let me stop sharing my command, my window, and let me move to the Canvas page. And here's what I'm going to show you. At previous chapter, chapter 3, you will see this PDF file that contains a summary or summarization of what we talked about last class. And here's another file. It's a summarization of how the tar file system works. So here's what I'm going to do. I'm going to give you guys a break for 15 minutes. At 7:30, we'll be back, and I will make this, since the class of today, it's not that one long, so I'll give you guys a chance to take the basic shell command exam today. Now, feel free to open the Linux command file that I sent you here and use it to help you answering the questions of the exam of chapter 3. So let me go back to Zoom. Where's Zoom? Here it is. Stop sharing. I'm going to pause my microphone, and I'll be back at 7:30. Go drink some water, have a rest, and come back at 7:30.